Меня зовут Денис Чернов. Я DFIR,
I'm Denis Chernov, an engineer from Solar4Ace. As far as I know, we're going to speak about Windows Scheduler. A few words about me. It's the incident reaction, it's the internal soft creation, incident investigation, data processing, and sometimes I co-write in the 4Ace blog. So I would like to start this with the interview-like question. So you're a system admin or a forensic, so it's a Windows Server of 2022, you need to check it for malware. Normally, people reply very quickly, and people say that they can do it with the standard utilities, and we often hear about auto-runs, the most popular tool. Many other people remember that it's forensic. We can do the analysis of the XML files from System32 tasks and the Windows logs analysis, but there is a subtlety. In 99% of the cases, if you do something out of it, you'll be able to find something, but there's just one thing when you do these four things and you will skip it. So we saw it in 2023. We had a very big case, which the customers started having some time ago, so they used proxy shell and they put a Microsoft Windows location alert task. It was a very interesting thing. The trigger launches twice a week at a certain time, at night. So it runs a command which does not alert the DPO tools. It copies this to the mail server, takes 2 hours and 30 minutes, and then it deletes, and it's a web shell requirement needed. So they've triggered that for 2 years in a row. Why is it so difficult to detect this? If you wanted to analyze the XML file, there was no such file. Looks like this. For example, if you wanted to check out the Windows file, it was a loaded mail server. The log lived for a few hours, the planner lived for a few days, and all of the logs rotated, and there was no such task registered whatsoever. It's interesting that it was not in the live utility output. Live utility output also missed them. So it seems like that there is nothing to worry about, but the thing is that it really works. And if you didn't know that it's just hidden from the live utilities, you would have to explain it for a long time. You would have written a nice report, and you would say, please remove the alert task, and you would see the empty scheduler, and whatever happens, something may follow. So the admin would say, I'd follow the recommendations. There were 4 of them, one of them to remove the alert task. They opened the planner, they opened the scheduler, they had completed all the other tasks, and they reported that everything went well. It could have said that there is no task, which is a nice thing, because there is no task, and it's true. And it could have not said anything. It also happens. Anything may happen, and most likely a malicious persist remains in the system. So if you don't know why it becomes possible, probably you've missed a few Windows updates over the last 10 years. So in order to start somewhere, you need to start with the basics. And the basics look like this. It looks more or less the same. I just took the course of DFIR and TH from 2022. It starts with Windows Vista and Server 2000, and it stores configuration from the directory C, Windows tasks, and the previous directory becomes legacy. The new files do not have an extension and are presented in XML files, which can read without using any special tool analyzer, which is good. And if you are planning an attack and you want to act covertly, you may want to avoid using scheduled task, because this log, the creation may be found in the Windows registry. This execution can also be found in Windows registry. And here's this registry key, which is called task cache. Please pay close attention to task cache. It's not written there in that course, but if you really wanted to figure it out, you just use the Eric Senderman's utility. It's called task cache, and it keeps this data, and it shows the version, it shows the ID, it shows the path, when it was created, when it was last time launched, when it was stopped, and what was the code that finished its work, and some other metadata, which sometimes is not useful at all. But there are some subtleties. Like I said, Task Cache was released in 2007 together with Windows Vista, and still since then we have not had any detailed information. We still don't understand completely what this Task Cache is all about. And this information has become obsolete and irrelevant since 2012. Starting from Windows 8, the directory C Windows System 32 tasks has become legacy. So here, if you really attended those courses, you still have quite a big gap in your knowledge. So let's go back to 2007. Back in the day, there was this interesting thing generated for Windows. If you see it for the first time, it looks quite complex, but it's quite okay. The blue one is task 1, all the rest is task 2. It was done for the system, not for the human being, so it looks like this. It has a few directories, the tree directory, which has tasks and containers. Task 1, and it can keep an index, a number from 1 to 4, and ID, which contains GUID tasks. Here you also see the tasks that contain similar things to directories, and the whole tree actually repeats C Windows System 2 System 32 tasks. Then we have the C tasks, which have the names that correspond to ID from tree, and each section contain the following values. For example, dynamic info, that's for Windows, that's binary structure with metadata. Then we have path, which corresponds to the path to the section in tree, and triggers, binary structure of triggers. The final four are difficult to speak about. These are the trigger-related sections. If it's boot-related, it would have the index of 1, and it would be contained in the first boot sector. If it's the second one, then the third one, plain, etc. In 2003, they added another hash value, which stores the hash of the tasks XML file in C Windows System 32 tasks. The rest is unchanged. So Microsoft decided so that the triggers of tasks would be kept in memory, and they wanted just to wanted the system to run faster. All the rest remained unchanged. Why do we need hash? It's a very important value which prevents the change of the XML files. You cannot just open the XML file and change the command. If you do so, you will have the damaged task and it will not run. Again, I should stipulate that it only started having it in Windows 7. The XML file protection was done in Windows Vista. It appeared in Vista, so it had been all thought about. And summarizing for Vista and 7, XML files are really handy, and you don't need to know a lot of forensics to read through these XML files. You just check who created this file and which command it launches. Files are protected from modification, With the task cache, we can make sure that metadata becomes available and visible. Since that XML file is the same as deleting the task, when you delete an XML file, still the task cache remains, and even if you delete the XML file. And some admins really liked it. And so, 2012, in Windows 8, significant changes were added to the location of the task definition store. The XML files continue to be populated in Windows System 32 tasks, but task scheduler actually loads from the definitions from the register. It was released as an article in 2024. They wrote about that, but the actual changes occurred a lot earlier. It happened in 2012. And I didn't see any quotes about these things actually happened. A lot of important changes took place. If we open task cache Windows 8, we'll see a lot of new values. There are not 3, there are not 4, there may be as many as possible. In actual fact, all of the XML data is currently kept in the registry. For us, forensics, the actions is very important, where the command line task is stored. The command line actually starts calc exe, but there is a binary, and we don't always know what exactly launches this task. Seems like that nothing has changed. The XML files are still in place, but in actual fact, it doesn't work that simply. In Microsoft, they thought that if they moved all those tasks to the registry, protecting registry files has become unnecessary, so the hash value does not work. Starting from Windows 8, it means that we can change the XML file, and when we analyze the system, it will not store the command line that is the actual one in the system. The second subtlety, the values protection do not exist because, it's not that difficult to reach this. You can acquire this technique in 5 minutes. You don't need to believe anything, because the mandatory thing is to action the path triggers. And previously it was in the XML file, it was protected. Now we don't have any protection available. So it smoothens the features appeared in Windows 8. For example, having this file in Windows 8 was still mandatory. If you delete the file, it will be hidden from the utility list and it will not work. Those of you who like the deletion of XML files should know that it's still alive. It's still XML file can be reinstated randomly if someone had deleted it. So in order to confuse the investigators, you cannot do it to confuse them. You restore it when you open the task scheduler. For example, the file was deleted, admin wanted to react to the infrared, he opened the task scheduler, and this technique does not work any longer. And it does not work for the files if the file had already been deleted. And the main feature here is that why they moved that from the XML file tree. We have the data, and we just check the auto runs and see the tasks launched. Seems like there are no changes, which is true. It looks bad, but it could have been even worse. But then 2015 followed. Microsoft wanted to create the best operating system in the world, Windows 10. Seems like that they just confused bugs and features. Whatever I've said so far has stopped being relevant. Having the XML file has become irrelevant starting from Windows 10. There may be no such an XML file, and after you reboot the system will work normally, but the XML file stopped recuperating.
You can open the file, you can start working with the task, and it will not work this way. XML file is created, and it gets modified only in case if somebody will deliberately create or change the task, so change the task planner. Most interesting is that we have bugs and features during live analysis. How could this happen? It's a question to Microsoft. What changed there? In 2015, in Windows 10, they added a new value to the tree. It's SD value. You can Google what it is. These are rights to launch the task, but actually these are rights to review the task. And please see that it's in a few instances in the tree. Microsoft would transfer tasks into the registry, and in Windows 8, they keep XML files in order to keep all the access rights. But in Windows 10, they decided to transfer access rights to the tree, and they are not in XML files anymore. Now let's talk about bugs and features. There were no live utilities in the task. When you get faced with this, then the first thing that comes to your mind, are we the first ones who noticed this, or did anyone notice it before us? This technique is well known. Second question, is Microsoft aware of the fact that Windows may behave this way? Of course they know. They were the first ones to report it. And the article looks the following way. They had an incident, they had an Asian apathy group half new, and they deleted the task. So the task was hidden, and they reported it in 2022. It's 2025 now. How many of you think this problem is still relevant for Windows? Does it still stand? Of course, this problem still stays, this feature still works. But they didn't miss it, they noticed it. If we just look for it, then we can find that in the mentionings of this story. It doesn't have a separate story, but in case if we're looking for information about half new, then they have something that it was hidden. Well, information is available, so okay, at least it works this way. Then we have community velociraptors. They have done the most, and they detected the story. Last time when I looked in this detects, they had a to-do status, and the point of detect is that they check the value of SD, and this velociraptor will hit these values, but they are not in release version, and in case if you don't have them, you need to code them yourself. But it makes no sense, because when we learned about this, we started looking at what happened in our incident, and we found out that we got faced with something different. We had a security descriptor in the task, but at the same time, we could not see this. We went further on to Google it, and we got faced with an article of colleagues from arisen. Actually, this article is not about forensics, it's about something else. But in the text, somewhere in the center, they're saying there are some cases that we can delete security descriptor of the task and it will get hidden. Also, we can make index equals 0, it will still hide the task as well. We can also delete the index as altogether, and it will work, but the task will not be reflected. So graphically, it works this way. We looked at this, and we realized that we need to detect it in a mass manner, preferably. I was on this task, and at some point I got astonished by Windows security system. How did it happen? I was not very much aware of the story. I read an article, and I was told, delete SD value. I deleted SD value. I wrote detect. If SD is, I didn't even write it, I copy-pasted detect from Velociraptor, and I did a check for cache. So the task got hidden, but detect didn't work. So I decided to debug my detect, and in my case, it was not cache, it was SD that was a mass of data of any length. Cache and empty massive data are different things. It's a different class of errors. Then I thought, what if I write hello instead of SD? The task got hidden, which means that detect of Velociraptor does make sense, but it's very weird. So we have a new rule of detecting. In case if SD is not a security descriptor, then the task will be hidden. So in case if we cannot parse the value, it will detect. Then I was thinking it's interesting to look for these features. Maybe I can find more of this. And the first thing that came to my mind is, what if I bypass my own detect? What if I create such a security descriptor which will be parsed but it will not be compatible with task planner. And I found one. I just took security descriptor and I equalized all the values to cache, and here's what I have. If I try to get it from an SD formula, then we'll get an empty row, that's it. Then I start playing with values, and I found out that this was not the only case. For example, we can fail to indicate the group in security descriptor, or we can fail to mention the owner in security descriptor. This way, we have a new rule. In case if the owner or the group equal cache, then the task will be hidden. It seems that we can make a blacklist of these values, but there are not three of them. Security descriptor is a complex structure. Here's one more that is different from the first one by one number, so you cannot make a list of all security descriptors. So here's the rule. We need to parse all the values of security descriptor. In case if the owner is null, then it's detect. But it's not all. Microsoft are writing in their article, in case if you delete an SD from the task, then it will be hidden. But if we look at the structure of task cache, or at the tree of task cache, then not only tasks have SD, but also containers have SD. If we delete SD from containers, then the container and what it has will be hidden as well. For instance, we can delete SD from evil container. We will not be able to find evil, and task 2 will not be found as well. Let's talk about the scale of the problem. Microsoft is writing in their article that the task gets hidden from the console version, from the graphic version of Task Planner. That's it. But if we create the same task, if we play with it, then we see that it also hides from PowerShell, from different commandlets. Also, it gets hidden from outer runs. And let me remind you, this is the utility that is usually disconnected from the infrastructure, and this looks for persistence, and this utility did not find this persistence. Sounds funny. Also, this task wasn't found by Nearsoft, and Tilde Sequeneer also could not detect it. Sequeneer is not a forensic utility, but admins sometimes use it in order to see what they have in the systems and in order to use it to delete something. All these softwares are common because of one indicator. They use WinIP to work with their tasks. So there's a conclusion. Even if you write your own software which uses WinIP to work with tasks, then it will not find this task as well. I checked it. While we're still on it, on this hidden task, let's talk about deleting. There is a paradox. In order to delete this task, you need to see the task in order to delete it. And there's an ultimate instruction. We can delete it from the registry. In order to do that, we need to open the register, and we need to delete 3 options: task 1 and the sections that start with A1. At the same time, it's recommended to delete the whole XML file if you have it, because we don't know what Microsoft will come up with in the next patch. What if they say that it can be automatically recovered? After that, you need to reboot the system and the task planner system. But since we're dealing with Windows, even here we have some features. Feature 1, if you have done manipulation with SD, then you can delete this task in case if you delete it with the help of the task planner. It has this functionality. In this case, you will see this task. But it doesn't work for those cases in case if it's hidden with the help of index value. But index has its own value. It can be deleted directly with the help of console, but it can be not only deleted, but also you can see what it does. And this case also doesn't work for the case of SD value. In case if you do it with SD, then you will get an error that it doesn't exist. And here you may think, peculiar, this task is hidden, but still you can interact with it, you can play with it. Maybe it's not a bug, maybe it's a feature. And you will be right, it's a feature. It's related to automatic delete parameter, and also with immediate tasks. So in Windows, you can create a task that will get deleted from the system automatically once the trigger gets matured and once the deadline is over. It's easiest to create this with the help of group policy. There is a button, immediate tasks. Then you will create a task that can be performed only once. If we see how does this task live, then we will see this life cycle. It's created as a regular task with this parameter, then it's executed, and the timer to delete it starts. And then the logic is different. The XML file gets deleted. Only 2 out of 3 parts of the registry get deleted. However, usually all of them get deleted. The tasks gets deleted, which has command line, and plain gets deleted in all that's necessary for the trigger to work. But the third one is still there, and the index is replaced to 0. Microsoft came up with this in order to mark that this task was deleted, but it has been there. So in case if you see index equals 0 value, then most likely, or it may be not an attacker, maybe not the criminals, but maybe, and you will not find this in tasks, in task cache, and then you may assume that it was a task with automatic delete. It's an interesting fact, but still the deleting is captured as usually. This is a separate function to delete a task, and it was developed in Windows 7. Again, from Windows 7 you can find these tasks where index equals 0. But this parameter started hiding tasks only beginning from Windows 10. So it was an old weird feature which was available in Windows 7, and it was improved for Windows 10. What's the reason for this? Not clear, but it's fun. If you think that all that I said was anti-forensics, then now we are in anti-forensics to the power of 2. Colleagues from arisen have an article about something similar, but not this exactly. They're writing that in case if we import the value of task into task cache, or in case if we modify them directly, then it will not generate events related to tasks. So in logs, we may not see tasks of creation or delete in the task. So in case if you build detect based on the fact that these events are available in the log, then beginning from Windows 8, they're not available because in Windows 8 exactly, they disabled protecting the tasks from deleting. Also, let me add to what all colleagues are saying. You can import any values. For instance, you can import your dynamic inflow, which is parsed by Zimmerman's utility. Dynamic info may contain not the values that are actually there. So this way you can substitute the time when the task was created. The minimal data set that is necessary for import, well, there are a few of them. You should put ID of SD index. You may not put their SD, but you don't want to get a random detect from Velociraptor. Then in tasks, you want to put parameters of paths, triggers, and actions, and in GUID, you want to put one of the things related to the section. We can import the hidden task. We can write index equals 0 from the start, or we can do an SD in such a way that the planner will break down. After input, you should restart the task planner or the system. Since we're not using WinIP to create the task, then in Windows 8, you will have to create an XML file manually for the task to work. There it was necessary. And here are all these scary stories. So the question is, what are we to do with this? Particularly if you have had some incidents and you're thinking, funny, have we had this task? Here is our statistics. We started monitoring all our systems, all the systems that go through us during analysis, and only in 2 of them we came across a case when index was equal 0. There were 0 cases where SD would be deleted, and all other systems were clean in this sense, based on the detect. So cases where with hiding the task account for less than 1%, so chances are quite low that you have gotten faced with it. But maybe you got faced with Asian PT group, Hafnum, Option and Paraguay, and I am the king. Microsoft wrote about Hafnum, and here we believe that Hafnum started this activity, but chance is not 0. Don't forget about it. During the last year, we have been seeing that attackers are remembering that anti-forensic tactics are there. For instance, recently we could see when phishing companies would use ATS files. We recently saw one of the criminal groups, which is usually running an infrastructure to break down everything as much as they can. They were using substitution of FM stamps in the system. When people remember about this, I don't know. There are 5 cases when XML file was deleted. And it's not clear who deleted it. If you're a forensic and if you are still not a fan of fast cache, then I can tell you it happens more often. These are absurd cases sometimes. Sometimes system admin wanted to respond to something. He found something and he runs to clean the system and he cleans the task with the help of deleting XML file in Windows 10 where it doesn't work anymore. Then it turns out that the system is compromised. It happens this way. There are other cases where we could see when XML file was eaten by the software in Windows 10, but task cache would still stay and work. It also happens this way. But for it to be somebody's ill intent, we have never seen this, but just be aware that it happens. How do you review tasks in the registry? When I asked these questions, I couldn't find an adequate answer. Because if you think about it, there is no parser of task cache in nature because Windows is supposed to parse it, but Windows does not parse it, so what are we to do is not clear. There's Zimmerman's plug. But if you look at the task in a more serious manner, then it's not user-friendly. If you have never dealt with them, then here is the plugin of Zimmerman. It says that there is a task 1, which was created on the 1st of January 2000. It's not true. In order to learn what it does, you need to take GUID task, you need to go into tasks, you need to see what is in actions, you need to look at X's. If you like looking into X's, then welcome. In Hexes, it may be there explicitly or it may not be there. If it's not there, then most likely it launches a common object. Also, we need to provide a quality service and you need to look whether the task is hidden from utility output. And maybe you can see that index equals 0 and the task is hidden. But what do you do with SD value? If you can parse it with your eyes, it's amazing, but most likely you cannot. Also, you need to see when the task was created in real life. You can go to the register and you can have a look at the registries of this task. They can be interpreted the following way. Plain partition is created only when the task gets created, and it's not supposed to change because there are no values there. Oh, this section is useless, actually, useless for the attackers. Then we have the tree, or in the tree section, and it's not supposed to change as well because all the values are static there. But since in this specific case there was a manipulation of index value, then we have a different timestamp. So we see when this manipulation was done. And the last one, stamp in tasks, gets updated every time when the task gets updated because dynamic enforce gets updated. But you may not have these stamps in case if somebody recovers the registry from backup. In this case, all the timestamps will be the same as the date of the backup. Maybe you can review the task this way once, 2 times, 3 times. But on the screenshot in tasks, apparently you can see 218 subkeys. If you review 218 tasks this way, this is what you're going to look like. This is why we thought and we wrote we coded a parser. By the way, you can upload it from our GitHub. We just posted on GitHub. It's open source. Plugin is open. You can use it. What's the advantage of our plugin? First of all, it parses the actions value, both for command line and for COM objects. Also, we added there SD processing and the whole tree processing for a specific task. Also, we can see the modifications of the tree, and we also see the value of index in this tree. Also, we added the alert column. According to the alerts that we're aware of, in case that there's a tick, then it went off, and it means that it worked. The unfavorable bug we or hiding in the original Zimmerman's utility. If you paid attention, it doesn't work in Vista and Win 7, despite the fact that task cache is available there. It just drops. That's because in Windows 8 is a little bit different, and it's available only in Windows 8 or Windows 10. And particular gratitude to those guys who wrote an article on separate PDF. I decided not to include it in the report because it's wrote about binary information. You'll just fall asleep. But this plugin is still alive. Conclusions. Evolution of Task Planner, 2007 to 2009. We got XML files and task cache. These were parameters of the task, and task cache would store some metadata. In the registry, registry was positioned as a storage of metadata and triggers. If we delete XML file, then the task will be deleted from the system. In 2012, Windows 8, task cache became the key storage of the task. Availability of XML file was still compulsory, but control of its integrity was switched off. So beginning from Windows 8, you should interpret XML file not as a task, but as a backup task. But in Windows 8, there is no opportunity to hide events from logs. So the defense was switched off. Oh, sorry. And in 2015, Windows 10, XML files are not compulsory anymore. The task will be deleted or will work. I mean, even if XML file is deleted and there are SD values and task cache tree, and you can delete it from utilities. Conclusions about utilities hiding. In case if you cannot parse a descriptor, in case if you cannot see who's the owner of the group, if they are if they equal null, and if the index equals to null or 0. It's very important. Always highlight the hidden task to the customer, to the executor recommendations, because if you don't do this, then they will not delete it. It's guaranteed. Then you will come back to this customer once again, and you will see that it's still running. It's good if the file starts the task, if some manipulations are done to the file. But in case of this task is a malware burden on its own, in case if it has a script, then it will stay and it will be up and running, and this is not good. And hiding from Windows logs. Attackers may work with a task without WinIP, then events may not be recorded in the log. It's not a bug, it's just it was overseen. It was not done by Windows. If task cache was implemented right, it would not be happening. But now it may just not work. The main conclusion, the main takeaway of this presentation, just stay tuned to our news, to our blog. In case if we missed something during the presentation, we have an article about this topic. All the technical information that I have just mentioned is available there. Also, you can find there a code for on C# to process actions. Most likely, it's most interesting to you. There you can find links to all the presentations that I referred to during my presentation, and also you can find there a link to our GitHub. So it all is in one place. Please use the QR code. And in order for it to be convenient for you to watch to stay tuned to our news, please sign up to our Telegram channel. There you will get news about recent vulnerabilities and indicators. Sometimes we share some practical information there. That's all that I have. Please interpret your tasks the right way. Thank you for your attention. In case if there are any questions about the plugin or hiding the task, you can ask. Where is the person with the microphone? Okay. Hello, thank you for the presentation. It was very interesting. I got a question about the parser. Of course, I have not looked into this. Is scaling possible? So can we do it with many hosts? What we have on GitHub is a plugin for Zimmerman's utility, and it works for one system only. Why Zimmerman's exactly? Because for the community, it would be the easiest. Zimmerman's will help to look at the image and at the live system at the same time. This is why it's implemented this way. In case if it's necessary for you to have it as a console utility, then we can do it. but right now it's not available in public. Are you detecting changes with some regular tool, or because you said that you cannot change it anyway, you cannot detect it? I'm not following the question exactly. In the plugin, we're checking those cases that I have just mentioned. In case if we cannot parse security descriptor, if there's no group owner, if index equals 0, no regulars. The value of security descriptor. About the blacklist you started talking about. And one last question. When for the criminal to create it, he needs admin rights. For instance, he wants to get persistent, get planted. Is it a sequence of actions, or, well, in your experience, they're saying that you have seen these cases. Does he create the task in one action and changes the descriptor, or in two actions? In case if it's two actions, is it logged somehow in events by ID? Maybe there's an ID for that to detect it. So first the task gets created, and then it changed the parameter in the registry. In our case specifically, it's a great question. In our case, we responded in 2023. We responded in 2023, but it happened in 2021. Even if the customer had something fine-tuned, in 2 years it could be erased many times. So there was nothing in the log. It's just a fact of life. The system is in the system. Try to experiment. Can you create it in an automated manner and change the parameters right away in one action? It can be. You can import it right away. That's the point. You can create a good file for import, and all parameters for hiding will be there, and it will be done in one action. You just need the rights for the system. Thanks. Oh, sorry. About detecting, there was one more point. I believe it can be detected, well, if you fine-tune logging of changes to the registry, if you set it up. Maybe this is what you wanted to hear. You can do this. Yes, an ID of the event, yeah.
Добрый день. Еще раз спасибо большое за доклад.
Hello. Thank you once again for the presentation. Editing rights and the rights to delete fields on top. Except for system, what other rights can we have? The user creates the task, he can enter the registry and adjust it. No, on business cache, only system has the right. Microsoft believe that it is enough. If you look into processes, then you can detect the task. For instance, in our case, this task was launched at night, at a random day of the week. You will not stay there at 6 a.m. and look into processes. If you do that, oh, great, but I doubt that you do it at night. Question is asked off the mic.
Эта фича не скрывает процессы.
This feature does not hide processes, so all processes will be visible. You want to see what are the tasks overall, which tasks are available, what is the persistence in the system of the attacker. You go in the GUI of the task planner and you will not find this task there, but processes of this task will be detected. You can see them, they will be visible.
Спасибо за доклад еще раз. Если я как атакующий...
Thanks for the presentation again. I'm an attacker. Instead of creating a task, I change system one and task cache and I add my payload there. Are there any cases when the system rolls this back? So the system rolls back the system tasks. Can you roll back the system tasks at all? Or will it hang? Honestly speaking, I can't answer this question, but it sounds good. It could work.
Не пробовали еще как-то дальше играться?
Have you ever tried toying with SSD? Because you obviously addressed the null value. Maybe if the owner was deleted or the group had been deleted, but the record is still there, maybe it makes sense that you start not from the black list, but you start from the white list, on the contrary. So the owner ID is a valid owner ID which matches the group, and the owner of the group has the appropriate rights. So when I saw that the tasks for users created by users has a non-standard descriptor, it will contain the users C. I can't answer it completely, but it seems like they may be different. So we can come up with a whitelist.
Просто такое ощущение, что null и ноль
It seems like that null
может быть недостаточно, с учетом того, что эволюция
may not be enough, because the evolution of the system of users in the system may be complex. There are a lot of things that can be found there by experienced people who know how to disassemble Windows. You may ask these questions to them. Another question: after restart, does the registry checked up for changes like plain text changes, etc.? I can't answer this question. I don't think that it's checked and verified for that. The system would ignore that error, and it would hide the task, like I showed you previously. Any other questions? So they told me to give this book to the author of the best question. It was about rewriting files. Who should I give the book to?